Before we begin our experiment, let's just get a little familiar with the equipment that we're going to use. And this is an ampere meter that we're going to use. So whenever we look at one of these digital meters, what we need to note is its range, which is the minimum value 0 amperes and the maximum value 5 amperes. This instrument is built to measure a minimum of 0 and a maximum of 5 amperes. What is the least count? The least count is the value of the smallest value measurable by this instrument. So the correct technical way to do it is to see this is 0 to 5, that's 5 amperes, and 5 amperes is divided into a total of 10, 20, 30, 40, 50 graduations. So that's 5 amperes divided by 50 graduations. Each graduation here is 0.1 amperes. Also, quite simply, we can see this is 1 ampere which has been divided into 10 parts. Therefore each of the graduations is 0.1 amperes. We have a second type of ampere meter over here. Now here you can see you can choose to have a maximum, you can choose to have a range of 0 to 500 milliamperes. 500 milliamperes is half an ampere, 0.5 amperes. So if you connect the wire here, you will get a more sensitive instrument, and as long as you don't want to measure anything over 500 milliamperes. And if you connect it over here, then you can on the same instrument you can measure up to 5 amperes. I am going to use these at 500 milliamperes just so we can get a greater deflection, and greater deflection means greater accuracy. So if I take that to be the range, what is the least count on this instrument? Well, let's just take this. 100 milliamperes is 0.1 amperes. So this is actually 0.1 amperes, and from 0 to 0.1 amperes it's been divided into 10 divisions. That makes it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That makes each of these divisions 0.01 amperes. So this has a least count of 0.1 amperes, and this has a least count of 0.01 amperes. You can also see here that this needle is to the left of the 0, and this is called a negative zero error. This means that whatever reading we get with this ampere meter will be a little less than the true value. So in order to account for that, we need to adjust it so that it has no zero error. Now, to take a reading on these ampere meters, you can see there's this mirror built into the ampere meter. Look at the reflection of the needle. When taking the reading, the needle and its image should align from directly above. Now, because I'm doing it to the phone, there's a slight problem. I'm having to tilt the phone, but when you use your head should be absolutely straight. So now if I use my eyesight, then this is in this position. The needle and its image are perfectly aligned. Okay, and so we have gotten rid of the zero error. Okay, and therefore we have our instrument is now accurate. Let's look quickly at the resistors we're going to use. This is a fixed 1 ohm resistor. This is an intermediate 2 ohm resistor. This is a 3 ohm resistor. This is a variable resistance, not a variable resistance. This is called a rheostat. And the thing about the rheostat is that we will connect it over here, and if we leave this slider in this position, then the current goes into this slider, and from the slider it moves into this wire, and it is to go through all of this wire to come out here. That gives it a total resistance of 22 ohms. But when we slide it, what happens is that the current is able to flow through this thick bar which has very low resistance and then into the wire. So as we slide this, we keep reducing the resistance because more and more of the length is covered through this thick bar, and it travels through less and less length of this nichrome wire below. And eventually, of course, if we do this, it has zero resistance because the current is able to travel straight through this and down into this contact. we'll be using this battery eliminator. You can see it has a voltage of 2 volts is where we're going to be using it. Remember, that's only an approximate voltage we saw in our previous experiments. Here's our friend the multimeter. Since we don't have a voltmeter, I don't currently have a voltmeter, I'm going to be using this. I've set it to measure a maximum of 20 volts. Okay, with that we're ready for our experiment.